Assalamu students. Today's lecture is going to be about work done in a gravitational field. Let's talk about gravitational field in the Earth surface. Let's say that this is the box and it's feeling a gravitational force in its surrounding. The work done is independent of the path followed by a body in a closed path. That means no matter which path you choose, the work done will remain the same. And it will remain the same because of this gravitational field which surrounds the Earth. Let us read about it. We know that the body is placed in space surrounding the Earth, experience a force which is equal to the weight and directed towards the center of the Earth, as shown in figure. Like over here, everything is being pulled towards the center of the Earth. This space around the Earth with which it exerts a force of attraction on other bodies is known as gravitational field. These arrows are showing the gravitational field which is surrounding the Earth. The gravitational force per unit mass of a body is known as gravitational field strength. Its SI unit is Newton per kilogram. If we carry a body in a closed path in such a way that the total work done will be equal to zero, such a field is known as conservative. That means no matter which path you take, the answer will come the same in a gravitational field, and that is why the work done in independent of the path followed by a body in a closed path. That means if it goes back to its original position, the work done will be the same. Now, let us consider how we can prove the statement now. Let us consider a closed path A, B, C, A in a gravitational field as shown in figure. Let's draw a figure in which we have to follow a pathway from C and then back to C again. So we move from point C to B and then from B to A and then come back to C again. Now, in this case, a body of mass m and weight W is carried along a closed path from C to B, then from B to A. The angle between the W and D2, that means over here, is basically at this moment is 90 degree, and the angle between BA and F is 180 degree. The angle between BA and AC is theta. So let's say BA this line and CA is this line, and the angle between them is known as theta. So let's assume that, as we told, that the angle between the W and D2 is 90 degrees. So we have a 90 degree over here between W and D2, and we are moving it from point C to point B. Here we go. So it moved from point C to point B. Now we have to calculate the total work done as the work done between C and B, and how much is work being done from C to B. We can calculate that the work done from C to B will be given as W, which is the weight, into D2, which is the displacement, which we have done already. So it will be equal to W D2 cos 90, because there was an angle 90 degree or perpendicular between the weight and the displacement. When we put cos 90, it will be equal to 0, and when we multiply this whole thing, it will be 0. So the work done from point C to point B is 0. Now if we move the body from point B to point A as shown, like over here again. So in this case, we have shown that the body moved from point B to point A, and the displacement was d1, and the weight was acting in downward direction, and the angle between them is 180. And we have already shown that the work done from C to B is basically 0. Now we have to find the work done in this case from B to A. The work done between B and A will be given as the work done from B to A will be WD1, or we can say WD1 cos 180, because the angle between the displacement and the weight or the force is 180 degree. So cos 180 is equal to -1. When -1 multiplied by D1 and W will get minus WD1. That means the work done from B to A will be minus WD1, and this is the work done from point B to point A on the same body. Now for the third part, to close the whole pathway, let's say it moved from point A to point C. Again, it moved from point A to point C. See the direction of the force, which is of yellow color, or sorry, displacement, which is of yellow color, has changed. Again, over here it was in upward direction, making an angle of 180 degree with the weight. But as soon as we move from point A to point C, its direction basically changed, and the D is basically D in this case, which is a purple color. Work done between A and C will be given as from work done from A to C, which is negative uh, dw cos theta, and dw cos theta we'll find from equation number 1. From the right angle triangle, d1 is equal to d cos theta. That means from a right angle triangle, we know that the basically if we want to convert it to uh, this value d1, the perpendicular theta part, as the angle is over here, so this is base and this is perpendicular and this is hypotenuse. So we can write d1 as basically the horizontal component of vector uh, d. So we can write down d cos theta as d1. So this is the horizontal component of the vector d, as we are looking as a vector form. From the right angle triangle, d1 will be equal to d cos theta. So equation 1, this equation will become from A to C minus d cos theta, it will be equal to d1. That means the value of d1 is again over here. One is of positive and one is of negative. Let's put net positive over here. So we have to write that down of perpendicular so that there's no confusion. So over here, although it is moving in downward direction, so the direction basically has a negative sign. So this is positive, as well as this point is also positive. So in this case, we can say that the work done is from A to C is given by WD1. Now, students, we are going to add all of the work which we have done already. Now, in this case, when we add up the total work done in the closed part A, C, B, A will be from C to B, from B to A, and from A to C. So from C to B, it was 0, the work done was 0. From basically B to A, it was minus D1, so it was minus D1. And from A to C, it is going to be WD1. So these two values basically cancel out each other. This is negative, this is positive, so these will cancel out and our answer will be 0. So the work done uh, in a closed path, if it comes back to the original question, that means no displacement was formed, so the work done will be equal to 0. So it is independent of the path basically followed. So let's assume that since work done in a closed path A, C, B, A in the gravitational field is 0, so the gravitational field is conservation field and is conservative field. That means in this case, no matter which path we take, if we come back to the same position again, the work done will be equal to 0. Now let us consider another example. Now consider another figure. Let the body be displaced in a gravitational field by two different paths. Let's assume, and we have two different paths in this case. The first path, let's say we are now starting from point A and we are going to point C, and we are assuming that this is path 1. Then what happens? The body flows from point A to point B, or slides from point A to point B, and covers a distance of d, and the weight of the body is w, which is downward direction taking an angle of theta, which is shown over here. Now in this case, the work done from path 1, which is from point A to point C, in this case, the total work done will be equal to WD cos theta from figure, and we can say that it is WD cos theta because this d cos theta equal to the d1 part, because d1 is a horizontal component of the vector d. So as we can see, the theta is over here. This is a horizontal component of vector d. So we can write it down, instead of writing down d cos theta, we can say it is just d1. So we can say the total work done from point A to point C is going to be WD1, where d cos theta, again I'm saying, is the horizontal component and which is represented by d1. Let's call this equation number 1, that in the first part which we followed, the answer was WD1. Now let's choose a different path, and now again we are going to the same position point C, but now we are not directly going from point A to point C, but we are going from another direction, which is from point A to point B and then to point C. So as you can see, the direction of the cube has changed, and the force or weight and the direction of displacement has the same direction now. Now in this case, the D1 path has to be followed. Now in this case we follow d1 path, it goes down, and now in this case the direction of the force and the weight basically and the displacement have the same direction. That is why the theta will be equal to 0. From work done in a path 2 from point A to point B and from point B to point C, we are now considering from point A to point B, the work done will be equal to, work done from A to B will be equal to positive d1 cos theta. It will be equal to cos theta will be equal to 1. So putting in the value of 1, we get wd1, or we can simply get wd1 is the work done from point A to point D. If we are moving from point B to point A, it will be negative. If we are moving from point A to point D, then it will be considered as positive. So the direction over here is showing the pathway which we are following. So it is positive in this case. Now we are going to move in a new direction, which is perpendicular to the direction which we moved, which is D2, which is making an angle of 90 over here, like this. Now in this case, let's assume that the motion is in this direction. Let me draw the positive again. This is positive and this is positive again, because the direction is an opposite direction. Now from B to C, as we can see, the direction is positive, but the angle between the displacement and the weight is 90 degree. As you can see over here, they both have 90 degree with each other. So putting in the value of theta is equal to 90 and cos 90 is equal to 0. So the work done from B to C is going to be 0. So the total work done using the indirect path will be equal to the total work from A to B and then from B to C. That will be WD1 plus 0. The total work will be equal to W into D1. So the total work in this case will be WD1, same as that the total work was done in the case of path 1. Now, what do we conclude from this one? Comparing equation 1 and equation 2, we conclude that the work done on the body in between any 2 points in the gravitational field is independent of the path followed by the body. Thus, the gravitational field is conservative and electrostatic and magnetic field are also its example. I hope you understand today's lecture. Inshallah, we'll meet again. Allah Hafiz.